Hi everyone, welcome to my channel Icon Teacher. I am Satya Prasad. In the previous two sessions, we have seen how to evaluate the limit using different methods, and also we have seen when to apply the left hand limit and right hand limit and how to apply left hand limit and right hand limit. Now, based upon this prerequisite knowledge, we are going to solve the problems of continuity and differentiability in this session. So, let's begin with the topic continuity. So let us see what is a continuous function. A function f is said to be continuous in an interval I if it is continuous at every point of the interval I. So let us try to draw the graph. So if we observe the graph, we could see that there is no break in the graph, which means this function is said to be continuous. And let us observe another graph. So where we could see that there is a break at a point, say x equal to a. So you could observe in the second graph that there is a break at a point x equal to a. Therefore, we say that the function is discontinuous at a point x equal to a. Whereas in the first graph, we could see that the function is continuous without any break in its interval. So a simple thumb rule to check whether a function is continuous or not is, if I am able to draw the graph without lifting the pen, then the function is said to be continuous. And if I have to lift my pen to draw the graph further, then we say the function is discontinuous at a point where I have to lift the pen. Well, how do you know that if the graph is not given, the function is said to be continuous or not? So the function is said to be continuous at a point if the limit is existing and is equal to value at the function. So we can say that the function f is continuous at a point x equal to a if the left hand limit is equal to right hand limit equal to f of a. So we have already seen in the previous video how to find the left hand limit. So LHL at x equal to a is given by limit x tends to a minus f of x, which is limit h tends to 0 f of a minus h, and RHL at x equal to a is given by limit x tends to a plus f of x is equal to limit h tends to 0 f of a plus h. So if the left hand limit and the right hand limit are equal, we have already seen that the limit is said to be existing only if the left hand limit equal to right hand limit. And if that is equal to the value of the function, then we say the function is continuous at a point x equal to a. So LHL f is continuous at x equal to a. F is continuous at x equal to a if LHL at x equal to a is same as RHL at x equal to a is equal to f of a. So if you observe this part, left hand limit at x equal to a equal to right hand limit at x equal to a, which means limit exists at x equal to a. And if you find the value of f of a, that means if f of a is defined, f is defined at x equal to a, and if we observe that the limiting value of the function is equal to f of a, then we say that the function is continuous at a point x equal to a. So let's try to summarize and say when is the function discontinuous at x equal to a. So the first case, a function is discontinuous at x equal to a if the first point is if f of a, that is value of the function at x equal to a, does not exist or undefined. And the second point is limit x tends to f of x does not exist. Or the third point could be both exist but are not equal. So let's try to go into detail of each point. F of a is not defined. So many multiple choice questions comes based on these 3 points. Based on the continuity problems, if you see f of a is not defined, then the function is discontinuous. So a question can come like this. Suppose we have f of x is equal to 1 by x, and we know that this function is not defined at x equal to 0. So f is discontinuous at x equal to 0. So this could be one of the question. So if we observe that f of a is not defined at that particular point, then we say that f is discontinuous at x equal to a. So in this example, f of x equal to 1 by x, f is discontinuous at x equal to 0. So limit extends to f of x does not exist. That means the left hand limit exists, right hand limit exists, but may not be equal. So that is the third point. Okay. So limit extends to f of x does not exist, which means left hand limit is not equal to the right hand limit. So let us take the example of second one. So at a point x equal to a, at a point x equal to a, we observe that the limiting value of the function, when you consider the left hand limit, it is b, and we consider the right hand limit, it is c. So the left hand limit is not equal to right hand limit, then also we could see that there is a discontinuity. Then third one is both exist but are not equal. That means the limit exists but they are not equal. So let us observe this graph. So at a point x equal to a, say the limiting value of the function is found to be b, and the value of the function is found to be c. So limit x tends to a, f of x is found to be b, and f of a is found to be equal to c. Here in this case we observe that the limiting value of the function is existing and the f of a is also defined, but still they are not found to be equal. So in that case also the function is discontinuous at a point x equal to a. So these 3 points are very, very important. The first point is, if f of a is not defined, then the function is discontinuous. Then the function is also discontinuous if limit extends to f of x does not exist, which means the left hand limit is not equal to the right hand limit. The third case could be both exist but are not equal. Now coming to the next point, polynomial function, absolute value function, exponential function, logarithmic function, sine function, cosine function, tangent function, rational function are defined within their domains are continuous. So which means all these functions are continuous within their domain. So suppose a question comes like, find the interval in which this function is continuous. So you can simply find the domain and tell that that particular function is continuous in that particular interval. For example, what is the interval in which polynomial function is continuous? We know that polynomial function has a domain R, so it is continuous for x belongs to R. So we can write like this. Polynomial function. So find the interval in which the polynomial function is continuous. X belongs to R because that is the domain. Absolute value function, modulus of x. Now this function is also having the domain R, so it is continuous for all x belongs to R. Then exponential function, e power x. Again the domain of this is R, therefore we can say that x belongs to R is the interval in which e power x is continuous. Then we have logarithmic function, log x to base a. Here also we say that x belongs to open interval 0 to infinity. So the function is continuous in the open interval 0 to infinity. Then coming to the sine function, sin x. So we know that sin x is also continuous for x belongs to R. So let's just try to pen down 1, 2, 3, 4, 5. So sometimes the question may be asked like, where is the function discontinuous for logarithmic function? So R minus open interval 0 to infinity will be the answer, or minus infinity to 0. including 0 will be the answer, where logarithmic function is discontinuous. So that's how the different questions can be asked. Now let us see the sixth one, that is cosine function. So cos x, also the function is defined for x belongs to R. Then coming to the tangent function, tan x. So tan x is sin x by cos x, and if you observe, cos x is equal to 0 if x is an odd multiple of pi by 2. So the function tan x is not defined when cos x is equal to 0. So the function is continuous for x belongs to R minus 2n plus 1 into pi by 2, where n belongs to z. So all the odd multiples of 90 should be removed from the real number set, because tan x is sin x by cos x. Similarly, if you are asked to find for the rational function, so rational function will be in the form of p1 of x by q1 of x, where p and q are two polynomials. So r minus the values for which q of x equal to 0. So x belongs to all real numbers minus zeros of the polynomial q of x. Zeros of the polynomial q of x. When we have p of x by q of x as a rational function, where p and q are two polynomial functions, this function is continuous for all x belongs to R minus zeros of the polynomial q of x, which means we have to eliminate those values from the real numbers where q of x becomes 0. Next, if we take further secant x is again 1 by cos x. So again we have to check for when is cos x 0. Cos x is 0 for odd multiples of pi by 2. So x belongs to R minus 2n plus 1 into pi by 2. And let us see for cosecant x. It is 1 by sin x, and sin x is 0 for all the multiples of pi. So x belongs to R minus n pi, n belongs to z. So the problems are very simple if you are able to find the domain. So in fact it looks like you are finding out the domain of the function, right? So I hope all of you understood. Now coming to the third point, let f and g be two continuous real functions, then f plus g is continuous, f minus g is continuous, fg is continuous, f by g is continuous, and k into f, where k is a real number, is also continuous function. So f plus g is called sum function, f minus g is difference function, f into g is the product function, f by g is the quotient function, and all these functions are continuous. Where are they continuous? Well, they are continuous within their domain, and we know that the function is continuous within their common domain. Whenever we say domain of the sum function, product function, difference function, or a quotient function, which means that they have a common domain. So the domain of this will be domain of f intersection domain of g, domain of g. Next, coming to the point 4, let f and g are real functions such that f circle g is defined at x equal to a. If g is continuous at x equal to a, then f is continuous at g of a, then f circle g is continuous at x equal to a. So we have seen what is a composite function. F circle g of x is given by f of g of x. So this is said to be a composite function where g of x is the input to the function f. Now f circle g is continuous at x equal to a if g is continuous at x equal to a. So g is continuous at x equal to a. And f should be checked for continuity at g of a. So f is continuous at g of a, x equal to g of a, g of a, g of a. Then only we say that f circle g is continuous at x equal to a. So once again, the composite function f circle g is said to be continuous if g is continuous at x equal to a and f is continuous at g of a. Then we say that the f circle g function is continuous at a point x equal to a. So these are some important points of continuity. Now coming to the concept of differentiability. The function is said to be differentiable if the left hand derivative is equal to right hand derivative. So we could see here the left hand derivative is obtained at a point x equal to a if limit h tends to 0 f of a minus h minus f of a by minus h. So this is how we find the left hand derivative. And the right hand derivative is obtained by writing limit h tends to 0 f of a plus h minus f of a by h. And then we say that the function is differentiable at x equal to a if left hand derivative at x equal to a is equal to the right hand derivative at x equal to a. Now one may wonder how to check graphically. Suppose you know the graph of the function. So where do you find the function is not differentiable? So wherever you could see that the graph has a sharp corner, then you say that the function is not differentiable at that particular point. So here suppose this point is having coordinates h comma k, then this function is not differentiable at x equal to h. F is not differentiable at x equal to h. Similarly, we may have a graph where you have sum of two modulus functions. So we may get a graph like this. So this function is not differentiable at x equal to a and at x equal to b. So in the first graph, if you observe, it's a v graph, a modulus graph, we observe that there is no break. So the function is continuous for all x belongs to R, but not differentiable at the vertex point. And similarly, here also we observe that this is a function where we have modulus of x minus a plus modulus of x minus b as a graph, where you could see that the function is not differentiable at x equal to a and x equal to b, though the function is continuous at x equal to a, x equal to b. So very useful interpretation while we solve the problems. So f of x is equal to modulus of x minus a is continuous at x equal to a but not differentiable at x equal to a, but not differentiable at x equal to a. So this is also one important point. So just by looking at the function, we can say the function is not differentiable at a certain point. For example, if I say f of x is equal to modulus of x plus 3 is not differentiable at we can simply observe that x plus 3 equal to 0 gives x equal to minus 3. So the vertex point is minus 3 at x equal to minus 3. Simply put x plus 3 equal to 0 and we get x equal to minus 3. So these are the different ways we can check whether the function is continuous or not, and also how to find the left hand limit and right hand limit. And I have also given you the conditions for discontinuity and continuity, and about the composite functions and when is the composite function continuous, and we have seen the differentiability, when is the function differentiable, that is when left hand derivative equal to right hand derivative, and how to find out the left hand derivative and right hand derivative. So I hope you understood. You can pause the video and you can write down the notes. The last point before I conclude this is all functions which are continuous need not be differentiable, but all functions which are differentiable are continuous. So the preliminary test for differentiability will be continuity. So if the function is not continuous, then there is no need to check for differentiability. You can simply say that it is not differentiable. So I'll just try to give a small example to remember this. Suppose there is the first test in class 11th, and if the child passes in class 11th, he is eligible to write the class 12th, and if he passes in the class 12th, then only he is said to be clearing the class 12th. So passing the class 11th is considered as the continuity test, and passing the class 12th is said to be the differentiability test. Now if I ask, if the child failed in 11th itself, then he is not promoted to 12th. So obviously there is no need of checking for differentiability test. And suppose the child passes the 11th. So it is not compulsory that the child pass the 12th standard, but the child is eligible to write the 12th standard test. So which means that all functions which are continuous need not be differentiable. But if I say the child passed 12th, so it is very obvious that the function is continuous, which means the child passed the 11th standard. So passing the 11th standard, if you consider it as a continuity test, passing 12th is considered to be the differentiability test. So based on this, there are lots of questions which are coming in the exam. All functions which are continuous are differentiable. True or false? Answer is false. All functions which are differentiable are continuous. It is true. A function is not differentiable if it is not continuous. Answer is true, because if the function is not continuous, obviously it has no eligibility to check for the differentiability. I hope it's clear. So somebody asks a question like this: what is a function which is continuous but not differentiable? So a simple example is f of x equal to mod x. So this function is continuous at x equal to 0 but not differentiable at x equal to 0. Remember, for all the functions, f of x equal to modulus of ax plus b. So if we consider the modulus function f of x equal to modulus of ax plus b, then this function is not differentiable. F is not differentiable at x equal to minus b by a. That means on putting ax plus b to 0, I get x equal to minus b by a. So this function is not differentiable at minus b by a, though it is continuous at x equal to minus b by a. So please make a note of this. We will discuss further. Now let us discuss few multiple choice questions based upon the concept what we have learned till now. So the first question: given function f of x is x square minus 4 by x minus 2 and g of x is x plus 2 where x belongs to R, then which of the function following are correct? F is continuous at x equal to 2, g is continuous at x equal to 2. Now let us observe this function. F of x is x square minus 4 by x minus 2, and we have clearly understood that this function is not defined at x equal to 2. So when the denominator becomes 0, this function is not defined. So f is discontinuous at x equal to 2. Whereas if you observe this function g of x equal to x plus 2, it is very clear that it is a polynomial function, so it is continuous for all x belongs to R. So f is discontinuous at x equal to 2, where g is continuous at x equal to 2. So the right option is f is not continuous at x equal to 2, g is continuous at x equal to 2. So option C is the right answer. Option A is f is continuous. No. So option A is not correct answer. F is continuous at x equal to, again B is not the right choice. F is not continuous at x equal to 2. It is right. And G is continuous at x equal to 2 because G is continuous for all x belongs to R. Therefore, the right option is option C. Now let us see the next question. A function f is said to be continuous for all x belongs to R. That means a function is said to be continuous for all real numbers. If it is continuous at x equal to 0, differentiable at x equal to 0, continuous at 2 points, differentiable for all x belongs to R. So if the function is differentiable, obviously it is continuous, because I gave just now example that passing 11th standard is passing continuity test, passing 12th standard is passing the differentiability test. If the function is differentiable for x belongs to R, obviously it is continuous for all x belongs to R. So the right option is option D. Now let us see the next question. A function f of x is sin x by x plus cos x where x not equal to 0 and is equal to 2k if x equal to 0 is continuous at x equal to 0. And we know that the function is said to be continuous if the limiting value of the function equal to value of the function. So Here if you observe, there is only one definition for x not equal to 0. When x not equal to 0 means x takes a value either less than 0 or more than 0, but not 0. So in such case, the left hand derivative, the left hand limit and right hand limit have the same definition for f of x. So here we can write limit x tends to 0, f of x is equal to f of 0. So there is no need of finding left hand limit and right hand limit because both have the same definition. So this is equal to limit x tends to 0. I plug in sin x by x plus cos x is equal to f of 0 is 2k. So we further simplify this. Limit x tends to 0 sin x by x plus limit x tends to 0 cos x equal to 2k. And we have seen that this value is equal to 1 from the identity, and cos 0 equal to 1 is equal to 2k, implies 2 equal to 2k or k equal to 1. So the answer for this is k equal to 1. So the right answer is option A. So many questions can come like this, where you will be given a definition for x not equal to 0 and something in terms of k for x equal to 0, and we will be asked to find the value of k in the CBSE multiple choice questions. Next question. The set of points where the function f given by f of x equal to modulus of x minus 3 into cos x is differentiable. So it is differentiable at what points is asked. So it is not differentiable at x equal to 3. Already we have seen that x modulus of x minus 3 is not differentiable at x equal to 3. So it is differentiable for all the other points except x equal to 3. So the right choice is all real numbers except 3. So r minus singleton set 3. State the function which is continuous for all x belongs to R. So let us try to observe these four functions. Sin x. Sin x is continuous for all x belongs to R because the domain is x belongs to R. So this is the right option. Now let us try to understand why these are not the right options. So x square minus 25 by x minus 5. So this function is continuous at what points? X belongs to all real numbers except singleton set 5, because at x equal to 5 this function is not defined. Then step x or greatest integer function. This function is continuous for all integers, non-integers. X belongs to r minus z. So this function is discontinuous for all integers. So it is continuous for all x belongs to r minus z. And signum function is f of x is equal to is continuous at for all real numbers except 0. So we can say that this function is continuous for x belongs to r minus singleton set 0, because here we could see the left hand limit is minus 1, right hand limit is plus 1, whereas f of 0 is 0. Therefore signum function is continuous for all real numbers except 0. So the right answer where the function is continuous for all x belongs to R is sin x. So the question may be one among this. So the different questions can be framed. Suppose the question asked is the function f of x equal to greatest integer function is continuous at, then we say x belongs to R minus z. The points of discontinuity f of x equal to step x is x belongs to z. So if we are very clear with the concept, we are able to answer all these questions. Next, the function f of x equal to greatest integer function, where step x denotes the greatest integer function, is continuous at. So as we discussed now, that the greatest integer function is discontinuous at all integers. So among the four choices, where is the function continuous? So we could see that there is only one option which is not an integer. So the right answer is option D. So remaining option A, option B and option C, we find they are integers, and the function is discontinuous at for all integers. Therefore the right option is option D. Now let us see the next question. The function f defined by f of x is x cube minus 8 by x minus 2 when x not equal to 2 and is equal to 12 when x equal to 2. So let us check whether it is continuous or not. So if we observe limit x tends to 2 f of x, If this is found to be equal to f of 2, then we say the function is continuous at x equal to 2. So let us check this. So limit x tends to 2, f of x is x cube minus 8 by x minus 2, and f of 2 is equal to 12. So we have to check whether they are equal or not. So as per the identity, this is equal to 3 into 2 square, because we have seen the identity limit x to the x tends to a, x power n minus a power n by x minus a equal to n a power n minus 1. In the previous video, I explained how to solve the problems using this identity. So 3 into 2 square equal to 12. So is it true? Yes, you got 3 into 4 is 12. So the limiting value of the function equal to value of the function. Therefore limit x tends to 2 f of x equal to f of 2. Therefore f is continuous at x equal to 2. So the right option is option B. Now let us see the next question. The function f defined by f of x is kx plus 1 if x is less than or equal to pi, and is equal to cos x if x is greater than pi. So if this function is continuous at x equal to pi, then we have to find k. Now here we observe that at x equal to pi, the value is kx plus 1, whereas when the value of x is tending to pi, which means when x takes a value slightly less than pi, there is one definition. When x takes a value slightly more than pi, there is another definition. So which means we have to find the left hand limit and right hand limit. So let's see how to find left hand limit and right hand limit. LHL at x equal to pi is limit h tends to 0 f of pi minus h. So this is equal to limit h tends to 0. We have f of pi minus h. Pi minus h is less than pi. So I have to choose the first definition. So f of pi minus h will be k into pi minus h plus 1. And if we plug in h as 0, we get k pi plus 1. And let us find the right hand limit. RHL at x equal to pi. So this will be equal to limit h tends to 0 f of pi plus h. So which is limit h tends to 0, pi plus h is more than pi, so it is cos of pi plus h, which is equal to, and cos of 180 plus alpha is minus cos alpha. So limit h tends to 0, it is minus cos h, that's equal to minus 1. So we got k pi plus 1 is equal to minus 1, because it is already said that the function is continuous, which means the left hand limit should be equal to right hand limit. So since the function is continuous, LHL equal to RHL at x equal to pi. So we get this as k pi plus 1 should be equal to minus 1. So on substituting k pi plus 1 equal to minus 1, we get k pi equal to minus 2, or k equal to minus 2 by pi. So the right option is option B. So once again, here in this problem, we are given that f of x is kx plus 1 when x is less than or equal to pi, and is equal to cos x if x is greater than pi. Since the definition is changing at pi, and we have to check for continuity at x equal to pi, we find the left hand limit and right hand limit at x equal to pi. So considering LHL at x equal to pi, limit h tends to 0 f of pi minus h, that is limit h tends to 0 k into instead of x we have pi minus h, so k into pi minus h plus 1. So on putting h equal to 0, we got k pi plus 1. So this is the left hand limit. Now considering the right hand limit at x equal to pi, we have seen that limit h tends to 0 f of pi plus h, that is limit h tends to 0 cos of pi plus h, and cos of 180 plus alpha is minus cos alpha. So cos of pi plus h will be minus cos h. So the answer is minus 1. And it is already given that the function is continuous at x equal to pi. So the left hand limit should be equal to right hand limit. So we get k pi plus 1 is equal to minus 1, or k pi equal to minus 2, or k equal to minus 2 by pi. So the right option is option B. Now see the next question. The function f defined by f of x is k into x square when x is greater than or equal to 1, equal to 4 if x is less than 1, is continuous at x equal to 1. So we apply the same method. So LHL at x equal to 1 is equal to RHL at x equal to 1. So we write this as limit x tends to 1 minus f of x equal to limit x tends to 1 plus f of x. So this implies limit h tends to 0 f of 1 minus h equal to limit x tends to 0 f of 1 plus h. Now all these problems rely on choosing the right definition. So for the given input 1 minus h is less than 1. So I have to choose the second definition. So limit h tends to 0 f of 1 minus h will be 4, and limit h tends to 0 when I take 1 plus h, that is more than 1, I write it as k into x square. So limit of a constant is constant, so it is 4 equal to, on putting x as 1 plus h, we get this as 1 plus h whole square, k into 1 plus h whole square. So this will be k into 1 square. This implies k is equal to 4. So the right option is option A. So f of 1 plus h, when we write the definition, f of 1 plus h is more than 1, so we have to choose the first definition. So we write it as k into 1 plus h whole square. So on plugging in f of 1 plus h as 1 plus h whole square and putting h equal to 0, we get k into 1 plus 0 whole square, that is k into 1 square. So we got 4 equal to k or k equal to 4. K equal to 4. So option A is the right choice. Now coming to the next problem. The function f defined by f of x is x plus 1 by 1 plus root over 1 plus x is continuous at x equal to 0 when f of 0 equal to how much? So f of 0 should be equal to the limiting value of the function, then only we say the function is continuous. So f of 0 should be equal to limit x tends to 0 f of x. So here it's given the function f defined by f of x is x plus 1 by 1 plus root 1 plus x is continuous at x equal to 0 when f of 0 equal to what? If the function is continuous at x equal to 0, then the value of the function should be equal to the limiting value of the function. So we write it as limit h tends to 0, x tends to 0, f of x is x plus 1 by 1 plus root over 1 plus x. That is the value of f of 0. So that is equal to, on putting x equal to 0, we get 1 by 1 plus root over 1 plus 0, that is 1 by 1 plus root 1, that's equal to 1 by 2. So f of 0 should be equal to 1 by 2. So option C is the right choice. So many students do the mistake of doing the rationalization of the denominator without actually checking for direct substitution. So first of all, we have to check by direct substitution. Only if you get 0 by 0 form, then you go for rationalization of the denominator. Otherwise, we can do the direct substitution. So I hope all of you understood this, and please pause the video and note down the problems. And if you like our video, please like, share and subscribe to my channel, and click on the bell icon for further notifications. These are very important problems in the point of CBSE board exams. Thank you.